In this video, we're going to describe a few different skills that are really important. I shouldn't say really important. They're important enough to where we should consider them now before we get too deep into some of the more advanced stuff. So combining like terms, distributive property, and exponents. Now we're not going to become professionals at working with these things, but we'll kind of explore the basics. So combining like terms. So what exactly are like terms? Well, let's just say, let's start with a really basic example. So if you have two apples and you purchase two oranges, can you say that you have four apples? Does that really make any sense? Well, probably not. We can't add apples and oranges and say we have four of either of the type of fruit. Now we could say we have four pieces of fruit, but that doesn't preserve either of the two units of the original two numbers. So similarly, sometimes we have situations where we have things like 2x and let's say 2x. Okay, so what does this actually mean? Well, in the cases where you have two apples, you have two things. When you have two oranges, you have two things. When you combine those, you have four things. Okay, well, if I have two copies of x, and then I have two more copies of x, how many copies of x do I have? Well, I would say that I have four copies of x. That same type of thing applies regardless of how many terms I have. So if I have 2x plus 6, and then I have plus 4x minus 7, any like units can be combined together. So if I have two copies of x over here, and I have four copies of x over here, well, that means I have a total of 6 copies of x. Now I had 6 constants. I removed 7 of those constants, so 6 minus 7, well, we know those are like, because those don't have any variables attached to them, so that would be 6x minus 1. All right, well, this doesn't matter what the powers are. So if I have 2x squared plus 3x plus 4 minus 7x squared plus 10. Okay, well, again, we're looking for things that are similar. So here, whatever x squared means, now we know that x squared means x times x, but for all intents and purposes, I have 2 copies of x squared. And I remove 7 copies of x squared. So I've got a deficit. 2 minus 7 means I have a deficit of 5x squareds. All right, well, if you think about it that way conceptually, as long as we're describing the same thing, we're describing x squareds here, we can combine any two things that describe them. Well, 3x, that's the only, I only have 3 copies of x in this entire expression right here. We call this an expression, by the way, because there's no equal sign. We don't call it an equation unless there's an equal sign separating things in here. Okay, well, and then I have my constants, 4 and 10, so that means I have a total of 14. Now, that doesn't have an x or anything attached to it, so that could be 14, negative, I'm at a deficit of 5 bananas, I have 3 apples, and 14 oranges. So when you think about it that way, combining like terms is just taking things that are similar and putting them together, packaging them up. Okay, so a lot of times we combine functions. Why are we doing this? Why do this? Well, usually we study functions. We understand those functions, linear, quadratic. And when we have a messy expression like 4x squared minus 10x plus 3x minus 4x squared plus 2, we can kind of see that it has quadratic and linear components to it. But in reality, when you say, well, I had 4 copies of x squared, I removed 4 copies of it, that means I have 0 x squareds left. We would say those just cancel out. I have a deficit of 10, but then I add 3, so I only have a deficit of 7 copies of x. So those are done for. And now I have this 2 left over. So in reality, what initially looked like a quadratic function turned into a linear because the quadratic terms canceled each other out and they disappeared. So this would be categorized as a linear function. So we want to answer, categorize a new function as linear, quadratic, etc. Okay, so distributive property. Distributive property is very useful because, again, it allows us to do this exact same thing, categorize a new function as linear, quadratic, etc.